So in this chapter, we have been learning that it is possible to evaluate interfaces without directly involving the users. So we have looked at inspection method and we have looked at analytics. These two methods to figure out how interfaces can be evaluated without directly involving the users. Another method that you can use is called predictive modeling. So the idea behind predictive modeling is that the designers are going to use some mathematical formula to figure out how well the user is going to perform with design. And I'll explain this to you in more detail a little bit later. So this is a very efficient way of evaluating designs because it's cheap, it's fast, you don't need to pay your users, you don't need to pay experts. But the limitation of this method is that it's only limited to evaluating certain tasks. For example, you can only use this method to figure out whether the key sequence that you have placed on the interface is optimal for performing a particular operation. So the tasks that you can evaluate with predictive models are very limited. Another limitation of predictive models is that they assume that the user is an expert and they are not performing any errors while interacting with the interface. The first model that I want to look at is called Fitts law. So let's start with a little history about Fitts law. So Fitts law was actually proposed by Paul Fitts in 1954. Paul Fitts was a psychologist trying to figure out what is the relationship between the size of an object and the time it takes to reach that object. His experiment turned out to be so influential that it's now being used in interface design. And the idea behind Fitts' law is very intuitive, but Paul Fitts' contribution is that he was able to give it a mathematical formula. He was able to describe this human behavior with the help of a mathematical formula. So let's look at this formula in a little bit more detail. So this is the Fitts law or the formula. So over here, this is T represent time. So basically, this formula is saying that the time it takes for somebody to reach a target is directly proportional to the distance between distance to reach the target and size of the target. So D represents the distance to reach the target and S is the size of the target. Okay, so the time to reach a target depends on the ratio of distance and size. Okay, so it's directly proportional to the distance and size, distance over size. Okay, so let's look at it in a little bit more detail. I know it's hard to understand this mathematical equation. So in this simplified version of the equation, we have ignored the constants here because they're not really necessary. These two variables, it's important to understand how these two variables are playing a role in influencing the time to reach the target. Okay, so let's assume that this is your mouse and I have been provided these 4 targets on the screen. Okay, so my starting position is here and I have to reach these 4 different targets. How long is it going to take for me to reach this target, and then I come back here, and then from here to here, how long is it going to take from here to here, from here to here? So I'm trying to figure out which target is the fastest to reach. So obviously, according to Fitts' law, and if you think about it logically, it will make sense too. According to Fitts' law, this target will be the fastest to reach. Why? Because it's closest to my location and it's biggest in size. Okay, so the ratio of distance over size is going to be really small. So if this distance is, let's say, 5 inches, right? It's not 5, but let's just, for the sake of talk, it's 5 inches, and then the size of the target is also, let's say, 5 inches, then the ratio of 5 over 5 is 1. Okay, so it's going to just take 1 unit of time to reach this target. Okay, now let's look at this target. According to Fitts law, it's going to take me longer to reach this target. Why? Because let's suppose that this is also 5 inches, right? Because these two sizes appear to be the same. So this is 5 inches, but obviously this size is smaller than this one. So this is, let's make it 1. Let's suppose this is just 1 inch is the size. Then the time it's going to take is going to be 5 over 1, which is 5. So it's just going to take me 1 unit of time to reach this bigger target, but it's going to take me 5 units of time to reach this smaller target, although both of them are same distance away from each other. Okay, so the bigger the target, the faster I'm going to be able to reach it. The smaller the target, the longer it's going to take for me to reach it. Okay, by contrast, let's look at these two. So this is also, let's make it 5 inches as well. The size is 5 inches. Let's make this distance be 15 inches. Okay, so now it's going to take me 15 divided by 5, which is going to be 3 units of time. So it's going to take me 3 units of time to reach this target. Okay, but this target, which is almost the same distance away from me, so let's make it 15, and the size of this one is 1, so it's going to take me 15 units of time to reach here. In conclusion, we can say that I will be able to reach a bigger target faster compared to a smaller target, okay, if both those targets are same distance away. The smaller target, I won't be able to reach it as fast as the bigger target, even if it's closer to me. Okay, so this took 5 units of time, and this one only took 3 units of time, even though the smaller one was closer, but because of its size, it took me longer. Okay, so the conclusion is that, but these two were the same size, and because this one happened to be closer, it took me only 1 unit of time to reach this target. So the bigger the target and the closer it is, I'm going to arrive at it faster. But if I'm gonna, for some reason, I have to place a target further away, then I should also make it a bigger size so I can reach it faster. Okay, so that's what the Fitts law is trying to say, and it's very intuitive. So the Fitts law basically predicts that the time to point at an object using a device is going to be directly proportional to the ratio between object's distance from the pointer and object size. So why is Fitts law important? So let's look at it with the help of some diagrams. So if the accuracy is important, we have to make sure that the target is larger and closer to the pointer. So in this particular case, this is the controller. So over here you can see that these two buttons are really big, and they have been positioned really close to the thumbs. As soon as the person holds this particular controller, they will be able to reach these two buttons really easily because they're the most important buttons. So that's why they were positioned, or they were placed here. Okay, it won't make sense to place these important buttons over in this corner, for example, because then they will be really hard to reach. Any button that is very important should be placed very close to the pointer's location. Okay, so another implication of Fitts law is that if you don't want the target to be frequently used or accidentally activated, then place it further away from the pointer and make it smaller. So in this case, again, because these two buttons are not probably very frequently used, and you don't want them to be accidentally activated because they're going to break the flow of the game, they have been placed further away from the position of the pointers, and they have also been made really small. So hitting them, it's not going to be very easy. And if you look at this closely, this is actually just the opposite of the first implication. So another implication of Fitts law is that at the corners and edges, the Fitts law also applies at the corners and the edges. So according to the Fitts law, the corners and edges are going to be very easy to reach. Okay, it's going to take very little time for the pointing device to reach these areas. Why? Because the edges, anything that is going to be placed close to the edge will be very easy for the pointer to reach, because as you can see, it's very hard to miss an edge. It's very easy to go to an edge. So when it's very easy to reach a place, an edge for example, or a corner, then that particular target is considered to be of infinite size. Although the size is not really infinite, it's just implying that it's easier to reach them. It's really hard to miss them. So the size is really big. So it doesn't matter where the position of the pointer is, it's going to, because the size is so big, the ratio between distance over time is going to be very, very little. Okay, so anything that you're going to place along the edge, or anything that you're going to place in the corners of a screen, that's going to be very easy to reach. And this is the reason we place some important buttons in the corners. So for example, the navigation button is of the let's say the Office, Microsoft Office, is always at the top along the edge because it's going to be very easy to reach. And similarly, the close button, the close minimize button of the window is also placed in the corners because those locations are easier to reach. So even though those buttons end up being very, very small, but just because their location is easier to reach, they are faster to reach. So the implication, why do we use Fitts law? Because our goal is to improve performance and reduce the chances of errors. Okay, now let's look at the summary of the, so in this chapter, we were looking at different inspection methods, and we had already looked at user testing in the previous chapter, and we came to the conclusion that the inspection methods can end up revealing some different usability problems that are perhaps missed by the users in the user testing. Then we looked at some walkthrough methods, and we said that those are very focused methods for evaluating small parts of the product. They are not for evaluating the entire system, but just focusing on certain tasks or certain scenarios, looking at the learnability of those parts of the interfaces. Then we looked at analytics, that was about collecting data about users' activities on a website or products to see which parts are being used and how they are being used. Then we looked at A/B testing, which is a form of large-scale experimentation. And then finally, we looked at Fitts law, which is a kind of a predictive modeling-based evaluation method that helps us figure out where to place different keys to increase their performance and reduce chances of errors.